So here is the program for the A to D converter. We can see that it has a couple of loops in it. The first loop here is the loop that actually does the A to D conversion. So this part cycles around as fast as we could get it to go, which turns out to be a bit faster, a bit slower than 10 milliseconds, seems like. And it's adding 1 to a register every time it cycles around, and it's looking at pin 3, which is the output of our comparator. And if the comparator goes high, it stops counting, and then it goes into a display loop. Now, we only have a few pins on this PIC, and so in order to get data in and out, we need to use a serial output. So we are using the simplest kind of serial output, basically another loop that just pauses and raises a pin high, pauses, takes it low, pauses, decrements the counter, the value of the register. So this will basically output a whole bunch of pulses, and we can change it so we can either see it on an LED and count them, or in this case we're going to look at them on the oscilloscope to see how many pulses coming out. And the more pulses, the more data the larger the number we stored in the register. So now let's go look at the I'll make sure I can see what's happening. Let's go look at the circuit. So here's our circuit diagram, and we can see we have an LED hooked up at the output of the PIC there. It's actually flashing so fast you can't see the pulses right now. We see a series of pulses just as a blinding flash. We can slow it down to see them if we want by changing the program. The circuit is very similar, actually, to the circuit we had. These are a couple of spare PICs over here, ignore those. To the circuit we used for the D to A converter. The only change we've really made is that our output amplifier that we used previously is now being used as a comparator. So the 3 pins here for an op amp are being used as a comparator, and the output of the compare is going over to N3 on the PICAXE. And we have the other changes. We have this LED, a 270 ohm resistor, driving an LED to ground out of this output here to display our serial data. And right now we have an oscilloscope probe hooked up to it, and if we follow the oscilloscope probe up, we can see the program running on the oscilloscope, and if we look close at that series of pulses, we'll see it's a series of pulses coming out. And what you see here is the ramp going up as we charge the capacitor. When the ramp reaches the same value as our analog input, and right now our analog input is being set down here to should focus with a bit of luck. I can't get the focus. It says it's 300. It's not going to show 300 for some reason. There we go. Now you can see it. 300 millivolts. So as I raise up the 300 millivolts, I'm going up in 0.1 volt steps. Go up and look at here what happens here. We should see the ramp go up, and the number of bits that come out from our register going up, and we're seeing that. So the ramp, the height the ramp gets to goes up, and we're adding a few bits each time for our 300 millivolt steps. I can keep going until I get to about 2 volts, which is about the highest it works on this. It says 2 volts on this. That's actually 4 volts in the circuit. Just like our A to D converter, 4 volts is sort of low. If I go past 4 volts, after that, not much happens. So not much happening. If I go back down below 4 volts, in fact, something crazy happens when I get too high. As I go back down below 4 volts, we see it going down, the ramp going down, and the digital value being read out from our A to D converter going down. And when I get to 0, we just get 1 bit out. That's the one count that we do, whether we go through the loop or not, the way that it's designed that particular program. So there's our single slope A to D converter. We have 1 ramp coming up that we're counting to do A to D conversion, and using the PICAXE. I did want to add a few comments about the program here. Let me move this out of the way. Actually, now I can't see the program. I want to be able to see where the program is. We had a couple of programming comments here. First of all, you may notice the way we've drawn the program is quite different than the way we drew it before. We encountered some problems using the flowcharting program. If the flowchart went off the page, particularly to the top, if it goes off the top of the page, we have trouble getting back up to complete loops. So we started putting our program across the page. Turns out the tool works quite well for sliding left and right and down, but it won't slide up. So if you make it slide left and right to extend loops, it works quite well. So you try to fit as much of it as you can on the page. You can always just switch to programming in BASIC too. The flowcharts are easier to think about than the BASIC, quicker to develop, certainly easier to debug, and in my experience we get them right first time. The second comment, what other comments do you want to make about it?
If you zoom out too far.
Right, zooming in and out on this program using either the zoom buttons up the top here or the zoom down here. If you zoom out in and out too far, the programs completely lose format. And we've had, the first time we wrote this program, it was completely destroyed and unusable simply because we zoomed out. I'm not going to show it. So don't zoom in and out. Once you start drawing, try to fit it on the screen and use the scroll feature to scroll left and right if you're using the flowchart. If you do that, it works really well, and it is a very quick way to develop these simple programs compared to the basic programming. And the last thing we mentioned in the last video, which was the
simulation.
Oh yeah, when you simulate the program, which you can do, make sure that when you simulate, so we're going to simulate now, and the simulate works. It's got some interesting features. It stops until you, first of all, you can see the internal registers by expanding. So here we can see our register is counting up, and we can stop it by clicking on the result. So we had 40, and you can see now, if I get it to zoom to focus, it's counting down now. Okay, but when you want to stop the simulation, just click on the, don't use this X up here, just click on this area over here, like that. Okay.